This is section 8.2, systems of linear equations in three variables. Notice actually that they kept out the inequalities, right? Interesting. So when you have three variables, then let's see, where do they have the result system? Well, they really don't. So they have it in three variables, x, y, and z, and three such. Now, how does it look like? Well, I'm going to scroll all the way down here. Those are not straight lines anymore. Instead, what they are planes. They're not square, but they're infinitely long or wide. So these are in three dimensions. The typical one is the one on the left here, where they intersect each other at exactly one point. And again, I don't like this particular drawing because they don't have to be perpendicular to each other. It could be at some other angle. There is a number of interesting solutions. So this is one of them where they intersect at one point. That's the normal one. It could be like this, where they intersect at exactly one line and you have infinitely many solutions. It could be where the three planes are actually one and the same. Like it was earlier, you have the same two lines, one and the same. So you have also infinitely many solutions. And then it could also be that they're all parallel to each other. So you have no solutions because they don't intersect anywhere. And it could be that only two of them are parallel to each other and the third one somehow cuts through it. Again, doesn't have to be perpendicular. Any angle will do. Well, at that point, we get an intersection line here for two of the planes, an intersection line here for two of the planes. Nicolas, I am recording right now. So that means that these here, yes, we do have a solution up here and a solution down here, but they don't intersect either. They're actually parallel to each other as well. So again, no solution overall. Okay, let's look at an example and let's see if I want to do example 1. Sure, that's because it's so easy already. They already give us a solution. So we have this plane where z equals 2 and x and y are whatever in that plane. So it's kind of like parallel to both the x and the y axis, so to say, or the xy plane. So we have the solution, and then they say, hey, let's just use the substitution method, and we plug in the 2 for the z. We figure out the y right away. That looks easy. We're going to come up with y equals -2, and then we plug in -2 here and the 2 for the z, and I believe we're going to come up with 14 maybe. Can that be? Yep, there it is. So x equals 14, -2, and 2 for the y and the z. All right. So here, solving a system equation using Gaussian elimination, we will see it again for matrices. What they're trying to do here is they're trying to get zeros right here, here, and here, which then leads us to the first example where we have a z, we plug it in here, we have a y, we plug in here, we have an x. All right, so they're trying to get rid of zeros here. First of all, what they do is they swap the first two rows. I guess they really want to have simply an x here. All right. And now what they do is they say, okay, we want to get a 0 right here. So we multiply the first with 2. So we have 2x minus 2x. Of course, here we're going to have minus 4y plus 4z minus 2 when we multiply by 2. So they do that here. Here, this is what I just said. Add these two, you come up with -2y plus 5z equals -8 when you add everything, the y's, the z's, and the numbers. And you get this one now for the new, this is the new second row, which I guess they call number 6 now. Oh, wow, this gets getting complicated, right? Now they're going to try to get a 0 right here. Well, in order to achieve that, multiply the first one with -3 all the way through, which is exactly what they do here. So that then added to the third row gives us this one, and this is our new third row. So they write it down again. There is the new third row. All right. Now try to get rid of the y's right here. Well, that's easy. Multiply this by 4, which is exactly what they do. Multiply by 4. There is that second row added to the third, and this is our new third row. 13z equals -26. Here it is. And now we have that triangle system of equations. Later on, we could call it a triangular matrix. Yes, Nicholas, it's a matrix. Yes, you may use the microwave. That's not going to bother too much. And then here, obviously in the last equation, divide by 13. So z equals -2. There it is, right? Plug in that -2 right here. That's going to be a -10. Add it to the other side, so it's going to be a +2. Divide by -2. So if I didn't make a mistake, then y equals -1, which is exactly what it says here. Plug in the y -1 and the z equals -2 into the first equation. And when you do that, it's late in the evening, I'll let you do this. So you come up with x equals 1, and the solution is this one here for the entire system. That in three-dimensional space would be the solution where all three planes intersect in one point. And then we're here, I explained that earlier. And yeah, here are these others here where we did system of equations where they either come up with no solution or dependent solutions where they're parallel. All right, and that's actually it for section 8.2.